Hello everybody. Today I am going to be going over lesson 4.3, another form of the equation from a linear relation. And this is for Math at 9. So this is the start of the next unit. And this section we're going to be exploring, as it says right in the title, another form of the equation for a linear relation. And so before we get into that, I'm just going to talk about the equation that we've used so far. So far, we've had equations that go in the format of y equals mx plus b. And usually what that means is that they come in the form of y equals something along the lines of, say, 3x plus 7. As an example. And what this is telling us is that, well, y still just stands for y, and x is still just standing for x, but the value of m would be 3, and the value of b is 7, and b is usually what we call a constant, and m is what we call a coefficient. So the coefficient is just the number you multiply your variable by right here. And a constant is an amount that you have from the very beginning. And we learned how we can find these different values when we have a graph, when we have a table of values. So how can we figure out what number we put here as the coefficient for x, and what number do we have to put here? And we've talked about how the rate of change is the number in a table of values would be the number we multiply by x, and the initial value we have in our table of values when x is equal to 0, that's the amount that we have right here, which is our constant amount that we have to add. So we've seen many different equations that take this form. We've had a few alternate forms where they would throw something at us like this, which we talked about, and it's really just, this is just the alternate way of writing these two statements here. We've also seen it with negative numbers and so on. So this is the format for the equation for a line, for a linear relation that we're used to seeing right here. But in this unit, we're going to be discussing different ones that we can add. So let's see here. So let's come down here to investigate. Well, first off, we can see here in our photo that we have two students, it looks like. And the first student is cutting a ribbon and the other student is measuring it. And they have two different lengths of ribbon right here, and each have a pair of scissors. So when we come down to the investigate section, we're given this scenario. Suppose you have a piece of ribbon that is 20 centimeters long. How many different ways could you cut it into two pieces? What are the possible lengths of the two pieces? How are the lengths of the two pieces related? And they want us to show this relation in words, in a table, in a graph, and as an equation. Okay, so first things first, let's try to visualize a 20 centimeter strip of ribbon. And what I'll do here is I'm going to take my graph paper that I have here, and I'm going to create a length of ribbon that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 centimeters long. So here I have my strip of ribbon. That is 20 centimeters long. And what they're asking us is how many different ways can I cut this strip of ribbon so that I have two pieces of ribbon of varying lengths. So what we got to figure out here is if we were to cut this length of ribbon, what is going to stay the same and what is going to change? Well, let's just take two quick examples of cutting this ribbon. First, we'll say cutting this ribbon. Remember, keep in mind that each of these blocks represents 1 centimeter. If I cut the ribbon right here, I would have one piece that is 1, 2, 3, 4, 5 centimeters long, and another one that is going to be 15 centimeters long. So there's one possibility. I also could have come along and cut the ribbon, say, right here at the halfway point. And that would have given me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on one side, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the other side. So I'd have two pieces of ribbon. In the scenario where we use the green to cut, I have two pieces of ribbon, one that is 10 centimeters long and the other one that is 10 centimeters long. I have another scenario where I cut it right here, and I have one that's 5 centimeters and one that's 15 centimeters. However, what stays the same is that no matter which way I cut this ribbon, the total length of both pieces is going to be 20 centimeters. So 10 plus 10 is 20. 5 plus 15 is also 20. So no matter how many times I cut this in half, or no matter, I shouldn't say how many times, no matter what lengths I cut this in half, or what lengths I cut this into, I'm always going to have 20 centimeters worth of ribbon. So this wants me to show in a table of values how I could express this. Well, let's first off, we'll say the first piece of ribbon is going to be called X. We'll say the second piece of ribbon is going to be called Y. So now, in this particular case here, I can make a really large table of values. I could start with 0 and then go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there's my table of values for X. If X is going to be 0 through 20, well then that should be able to tell us our values for Y, because let's just say I cut this right here, meaning that I have one piece that in X that's worth 0 and one piece for Y that is worth 20. So I'll put my Y values here, so that would be 20. Now, if X was worth 1, then Y would have to be 19. And then if X was 2, Y would be 18. So if my first piece of ribbon, no matter where I cut it, is 0, the second is 20. If my first piece of ribbon is 1, the second is 19. If the first one is 2, the second is 18. And this pattern continues all the way down. So this would be 17, 18, 19, 20. Oh, going the wrong way. What am I doing? 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and of course 0. So no matter what I do to cut this particular piece of ribbon in half, I keep saying the word half, to cut this ribbon into 2, I'm always going to have 2 pieces, and when I add the lengths of those 2 pieces together, it's always going to equal 20. 1 plus 19 would be 20. 2 plus 18 would be 20. 0 and 20 is 20. 3 and 17 is 20, 6 and 4 and 16 is 20, so on and so forth, all the way down. So what stays the same is no matter what, I'm always going to have two pieces that add up to 20. So can the two pieces of ribbon be any length? Absolutely not. Both pieces of ribbon have to be within the confines of this 20 centimeter ribbon, which means you can't have one piece of ribbon that is 40 and another one that is 16. That would be too much. So the values that we can use have to be between 0 and 20. They can't be higher, they can't be lower. So our two main variables in this case are going to be x and y, where x, we can say in this case here that x would equal ribbon 1, and y would be ribbon 2. So x and y, our values for x and y are going to be the length of the first ribbon and the length of the second ribbon. And now, in this is one of those situations where I always say that x is the independent variable and y is the dependent variable. But since we have a closed system here where we have 20 as our maximum and 0 as our minimum, and it doesn't keep going in all directions, really, x and y both depend on each other. I can't have a situation where x is 3 and y is 42. Every time x is 3, y has to be 17, but the reverse is true. Every time x is 17, y has to be 3. So they're both sort of dependent upon each other in this situation. So here we have our ribbon and our table of values, and we are also told that this needs to be viewed, we need to think about this not just in a table of values, but also in a graph and as an equation. We'll come back to in words in a moment. So when I go to graph this table of values right here, I can go to draw my graph. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And of course, going up, we need the same numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Well, this extends up into where I'm writing, but it's all right. So first, we'll take the situation where we have our x value of 0 and our y value of 20, and we'll mark that point here. So an x, we'll put our zeros on here too. This would be 0 and 0. This is our x, this is our y axis. So when x is worth 1, y is worth 20, which is way up here. So then x is worth 2, and then y is worth 19. So we have a steady line that starts to form directly like this. So you can see this is forming a straight line as x increases, y decreases. But we could also view it as y decreases, x increases. Sorry, as x decreases, y increases. So here we have our line, and what I'm going to do is I'm going to take these points and I'm going to join them. And the reason I'm going to join them is because we have to think about the type of data we're working with. And what I mean by that is, if I were to scroll back up here a little ways and look at our ribbon, all of the examples where I cut the ribbon were right here, where I had a full 5 centimeters, or a full 15, or a full 10 and another full 10. But I also could have taken this ribbon here, and I could have cut in the ribbon, say, right about here, which would be right in the middle. So what that would have left me is that would have left me with a half a piece right here on this side, and then a half a piece on this side. And then I would have had 1, 2, 3, and then this would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So really this would have been 16.5 centimeters, and the one over here would have been 3.5 centimeters. So because these can be cut in halves, and it doesn't even need to be 0.5, it could be 0.6, it could be 0.9, and so on. So each individual fraction of a centimeter between 1 and 20 would be included. So this is not discrete data. This is what we call continuous data, because any number between 0 and 1 is a valid number. As an example, 0.75, 0.25. We could cut a piece of ribbon that is 0.25 centimeters long, and then have another one that would be 19.75 centimeters long. So because any number, even the fractions or the decimals between these numbers count, we would join our line, or we join our dots with a line, because that is continuous. Unlike the other situations we discussed, where if we were talking about going and renting a DVD, you cannot rent 1.25 DVDs. That's what we call discrete data. That's when you do not join the line. But in this situation where it's continuous and each amount counts, we join it with a line. So now we have a table of values, we have a graph, and now we can think about this in terms of an equation. So here we can say, if we're looking for an equation and we have a table of values, so remember, when we want to figure out our table of values, we always start with saying y, or whatever our dependent variable, in this case y, equals. We can start by saying y equals, and then it is always going to be the rate of change between these variables. So this here is going down by 1 each time, -1, -1, -1. So y equals -1, and then that gets multiplied by our independent variable, which in this case is x. So y equals -1x plus, or sometimes it could be minus if it's a negative number, but since this case we don't have any negative numbers in our table of values, we look at what we call, remember, the initial value. So right here. So the initial value is whenever x equals 0, the value of y is what we call the initial value, and that is the amount that we will add to the equation, plus 20. So now let's just verify this equation works for a few of our numbers. So here I can say y equals -1 times, and I'm going to pick our first number, which would be 0. So -1 times 0 plus 20 equals 0 plus 20, which is going to equal 20. So now we've clearly proven that when x is equal to 0, y is equal to 20. And here we have 0 and 20. We'll just do this 2 more times just to confirm what we know. So -1x plus 20. So in this case here, we're going to fill in the value for where x equals 1 plus 20. So now we have -1 times a +1, which is going to be -1. And I still have to add my 20. So -1 plus 20 is 19. So again, when x equals 1, y equals 19, which is exactly what we see up here in our table of values. We'll do one more quick example just to be 100% sure. This time we're going to take the value of x and make it 2. -1 times 2 is a -2 plus 20. So -2 plus 20 is going to equal 18. And as we can see, when x equals 2, y equals 18, which is exactly what we have up here in our table of values. So this equation that we've come up with right here indeed does work. So now in words, what we can say. So now we're going to just describe this relation in words. So now when I go to describe this in words, I'm gonna, one moment here. All right, so now in words, so now we've already figured out that as x goes up by 1, y goes down by 1, with a maximum and a minimum of 20. So if I wanted to put this in words, what I would say is, as x increases by 1, y decreases by 1 with a maximum value of 20 and a minimum value of 0. Okay, so that should hopefully make it a little bit clearer in words. So I was able to write this here in words after I figured out the information over here in my table of values. So first I created the table of values from the information. Then I created a graph. Then from those I created an equation to get the relationship between x and y. And now that I know the relationship between x and y, I was able to verbalize it in words. As x increases by 1, y decreases by 1 with a maximum value of 20 and a minimum value of 0, meaning that neither x or y can go above 20 or below 0. Okay, so now let's go down further to this next section and connect. And here it tells us, let two integers have a sum of 3. Okay. So we have two numbers anywhere. When they say integers, it means it could be a positive number or a negative number. And when they say sum, they're saying two positive or negative numbers that can add up to 3. Let x and y represent the two integers. Here is a table of values to represent the relation. So they're saying if we start with -6 and then we add 9, we'll get to 3. -4 and 7 equals 3, -2 and 5, 0 and 3, 2 and 1, 4 and 6, and then 6 and -3, or 4 and -1, and then 6 and -3. So they've taken these points and they've graphed them right here in a graph. And it says the points lie on a straight line, so the relation is linear. Yes. We can write this linear relation as first integer plus second integer equals 3. Okay. Then the linear relation is x plus y equals 3. So this here is a new form of the equation. And if we were to take this same example that we have up here, where we have our equation, and we wanted to put this into the same process, this is what we could say is, we'll do a little quick algebra here. And now I know some of you aren't as familiar with this type of algebra, but I will show you quickly as I can up here how we can turn this equation into the same format that they had below. So we start with y equals negative 1x plus 20. And now what I want to do is I want to get my 20 on one side of the equal sign, might as well be this side, all by itself. And that means I have to get this negative 1x gone. Great. So in order for me to get rid of this, I need to do something to this side of my equal sign, but in order for me to keep my equation balanced, whatever I do to this side has to also occur to this side. So if I have negative 1x plus 20, and I want to get rid of this negative 1x that I'm adding to my 20, well, the opposite of adding negative 1x would be to subtract negative 1x. And if you recall, when I subtract, so if I was to subtract negative 1x from this equation, really that's the same as me just saying, so if I say subtract negative 1x, recall, when you are subtracting a negative number, it is the same as adding it. So really, what I have here is I have negative 1x plus 20, and then I'm going to go, and then I'm going to add 1x. Because remember, subtracting a negative is the same as adding a positive. So really what happens in this situation here now is that by me adding positive 1x to the negative 1x, these two reduce to 0, leaving just 20 by itself. And I can rewrite what I have on this side of my equation the same way. So rather than writing negative 1 or subtract negative 1x, I can write this as y plus 1x. Now, when I write this out on its own, I have y equals, oh, sorry, not equals, the equals is going after, y plus 1x equals 20. Which is exactly what we talked about here. When you add the value of x and y together, they're always going to equal 20, whether it is 5 plus 15, 10 plus 10, or 16.5 plus 3.5. When you add them all together, they're always going to equal 20. And since I have 1 times x, I don't really need to write the number 1 in here because it's already implied that 1x is just x. So really, I can say y plus x equals 20, which is the same form of the equation that we had in the next example. But this equation is still equal to this equation right here. These two equations are the same. They both give you the same value. So, even though we're used to seeing the equation in this form, y equals mx plus b, in this situation we have y plus mx equals b. Just a different way of writing this equation. So yeah, that form that we are learning to use this equation in is what we call, so yes, so we have learned y equals mx plus b, and now the new form of the equation that we're using is just going to be y, oh, I don't want to use yellow here, y plus mx equals b. Same values, the same values. The m here is still the same as the m right here. And the b right here is still the same as the b right here. We'd still find these values the same way we would. It's just we rearrange the equation in a different format. Okay, so let's go back down here to connect. And we saw how they have, then the relation is x plus y equals 3. This equation has both variables on the left side of the equation. It illustrates another way to write the equation of a linear relation. So now it says, suppose one variable does not appear in the equation. So this would be a scenario where if we have one value equals 0, the other one has another value right here. So let's consider that. Suppose x does not appear in the equation in y plus x equals 3. That would mean that x would have been 0, which means that y would have to equal 3. So to graph this equation, y equals 3, for every single value of x, since x doesn't exist, y is just going to be 3. So that forms, you go up 1, 2, 3 spots on our y-axis. And we now have a line going straight horizontally across the y-axis, going through our y-axis at 3. To graph this equation on a grid, plot the points that have a y-coordinate of 3. All points lie on a horizontal line that is 3 units above the x-axis. So by removing x from the equation, we had y equals 3, which gives the value of a straight line going through here at point 3. But let's just think of it the other way. Suppose we didn't have a y value. Suppose y does not appear in the x plus y equals 3 equation. Then we have the equation that x is equal to 3. To graph this equation on a grid, plot all the points with an x-coordinate of 3. So here we have a graph, 1, 2, 3. Here's the third spot on our x-axis. And now this forms a vertical line going straight up and down that goes through our x-axis right at point 3. To graph this equation on a grid, plot the points that have an x-coordinate of 3. All points lie on a vertical line that is 3 units to the right of the y-axis. So, if we remove one of the variables, if we remove x, it's always going to form a horizontal line through whatever value y equals. It's going to go through that point on the y-axis, and it's always going to be a straight horizontal line. If we're missing the y-coordinate, or if y equals 0, then we're always going to have a vertical line that is going to be going through the x-coordinate at wherever value of x here. Okay, so these are just ways to be able to graph straight lines, straight horizontal lines and straight vertical lines. So, now we're given this definition right here. The graph of an equation x equals a, where a is any value or any integer value, where a is a consistent or is a constant, is a vertical line. Every point on the graph has an x-coordinate of a. and it's always going to form this vertical line. The graph of an equation y equals a, where a is a constant, is a horizontal line. Every point of the graph has a y coordinate of a. Okay, so now we're given a few examples right here. Before I go down and I look at all the solutions, let's just look down here and see this first one here. For example 1, graph and describe horizontal and vertical lines. For each equation below, graph the equation, then describe the graph. Okay, so I'm going to look at this first one, a, x equals -4. And I'm going to come over here to where I have my graph. Now I have the equation, wrong color. X equals -4. And I'm going to create a graph right here. And here we're going to have 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to have -1, -2, -3, -4, -5, -6, so on. And then here going up, we have 1, 2, 3, 4, 5. And then going down, we have -1, -2, -3, -4, -5, and so on. So now, when I have a graph that says -4, x equals -4, recall what it says over here. When you have x equals a, and in this case it's going to be -4, it's going to create a vertical line that goes through point A. And in this case here, x is -4. So what this is going to do is it's going to create a vertical line that's going to go through our x-axis right here at -4. Remember, this is our x-axis, this is our y-axis. So when we have x equals -4, the -4 is referring to the -4 on the x-axis, not the -4 on the y-axis. So now that we have that point, all other value where x equals -4 will be put on this line. And so on. So now, if we come back over here and we look at this next situation where we have y equals, let's scroll this up slightly. We have y plus 2 equals 0. So we will come over here and I'll talk about the equation y plus 2 equals 0. So now, in order to have this in the similar format to this equation down here, I need to get y on its side all by itself, or on this side of the equal sign all by itself. So the way I can do that is by doing the opposite. The opposite of adding 2 would be subtracting 2. This here will reduce those numbers to 0, thus taking them out of the equation. But I can't do that on this side of my equal sign unless I do the exact same thing on this side of my equal sign. So what occurs is this plus 2, take away 2, reduce each other down so that I'm left with just y right here. And then if I have, which is left me with y equals 0, subtract 2. And so finally, I can say y equals -2 because 0 take away 2 equals -2. So now I have this set up here. And this is telling me y equals -2. So when I look at my graph that I have, that I've already started, y equals -2. Well, this is where -2 is on my y-axis. And now every value where y equals -2 will get a point added to it. And this forms a horizontal line that is -2 away from the x-axis. So now, this asked us to describe each of these lines. So first things first, when we have the equation x equals -4, we can say that this produces a vertical line that is -4 units from the y-axis. Okay. So now when we look at the scenario here with our y value being -2, so now that we know the value that y equals -2, we can say this produces a horizontal line that is -2 units from the x-axis. There we go. So that is how we can describe both of those lines. So the first one, this red line here, created by x equals -4. This produces a vertical line that is -4 units from the from the y-axis, and here is our y-axis, and it is 1, 2, 3, 4 units away. And this green line right here is produced by y equals -2. This produces a horizontal line that is -2 units from the x-axis, and here it is. And it is, of course, 1, 2 units away. So now, when we look, oh, I also have this other one that I missed here. C, well, we'll just look at the example to see how C, because actually, I'll do C over here, because C is going to have a little bit of algebra involved as well. So C is going to equal, let's see here. C is going to equal 2, oh, that one was green here. 2x equals 5. So now, in this situation, I want to do something similar where I have x alone on this side. Yeah, x alone on this side of my equal sign. Sorry, on this side of my equal sign, right here. So this 2 really means 2 multiplied by x. And the opposite of multiplying a number would be to divide by that number. So if I want the 2 to get reduced to a 0, or actually I shouldn't say a 0, if I want the 2 removed from here, I have to divide by 2 because it's the opposite of multiplying by 2. But I can't do that to this side of my equal sign unless I do the same thing on the other side of my equal sign. So this makes these 2 here reduce out. And I'm left with just x equals 5/2. Now I can leave it with a fraction of 5/2, but it's probably better that I work this out into a whole number. So, but 5/2 really means 5 divided by 2. So 5 divided by 2 is going to equal 2.5. So x equals 2.5. So if I was to graph this, x equals 2.5, if I was to say x equals 2.5, what that's going to do is that's going to create another line that is going to go through the x-axis right here at about 2.5. And this 2.5 is going to go all the way up here. So just like what we had in this here, sorry, with x equals -4, going right here, -4. Here, this is 2.5, so you're going halfway between 2 and 3, creating a vertical line right here. Okay, so when we look at our solution, it should match exactly what we have here, and it does. It says here that the x-coordinate for every point is on a line that is -4. So it's forming a straight solid line, which tells me that really what I could have done up here, now that I have my dots all connected, I could have really connected each of these series of dots with a straight solid line, because really it could be any point, even the fractions of points between them. So yes, these would all be able to be, these are all continuous data, so that they'd all be able to be connected. For B, we can see here that it is going through the x-axis, or sorry, the x-axis right here at -2. So y equals -2. And if we continue on, we can see the same thing. 2x equals 5 gets turned into x equals 2.5. So we're able to see that this is a line that goes between 2 and 3 horizontally. So now let's look at example number 2. Example number 2 here, it's asking us, it says, graphing an equation in the form of ax plus by equals c. Oh, so this is the form of the equation. So I guess up top here, I can go back and change that. Ax plus y equals c. So really, they're just saying that this can be rewritten as ax plus by equals c. And really all this is they're telling us, in this case here, m is just being replaced by a. It's still just another variable saying it's the coefficient attached to a. There is no coefficient in front of y here, but it is essentially whatever number would multiply by y. And b and c are more or less the equivalent in this situation. So let's come back down to example number 2. So in example number 2, it's saying, for the equation 3x take away 2y equals 6, make a table of values for x equaling -4, 0, and +4, and then graph each equation. Okay, so here I'm going to come over and I'm going to write my equation down just so I have it. We know this equation is going to be 3, it's going to be 3x take away 2y equals 6. And notice this still does follow the form of ax plus by equals c. The only difference is that in this case, a is equal to 3, b is equal to -2, and c is equal to 6. So we're still following the format of this equation, ax plus by equals c. Even though this is subtraction, the reason this is subtraction is because the value of b in this equation is -2. So ax plus by equals c. We're still following that form, that equation right here. So what this wants us to do is, we want to create a table of values. So I can come over here and create a table of values. First things first, we're going to have the table of values of x and y. There's only going to be 4 values. We're going to have -4, 0, and a +4, not a +2. So we're going to replace the value of x in this equation with -4, then with 0, then with +4 to fill these in. So first things first, I have 3 times -4 subtract 2y equals 6. So now what we're essentially going to do is we are going to solve for y using our algebra skills to figure out what the value of y will be when x is -4. In order to do this, we have to follow our order of operations and make sure we stick to our algebra rules. First things first, though, is we're going to multiply this 3 times -4. 3 times -4 is going to give us -12. Take away 2y equals 6. So now the next thing I want to do is I want to get rid of this -12 right here. So -12, the best way to get rid, which really means subtract 12, the best way to get rid of a -12 would be to add 12. But again, I cannot add 12 to this side of my equal sign unless I do the same on the other side. So I have 6 plus 12. That causes this plus 12 and this minus 12 to reduce out of my equation. And I'm left with -2y equals 6 plus 12. So now, in order for me to reduce this -2 out, I need to divide this side by -2, but I can't do that to one side unless I do that to the other. This causes these -2's to reduce out, and I'm left with y equals 6 plus 12 divided by -2. So now, if I keep going, I now add my numbers on in my numerator, 6 plus 12. So I'm left with y equals, so 6 plus 12 is 18 divided by -2. So y is going to equal, well, 18 divided by -2 is a -9, because I have one negative number here, which means my answer is going to be a negative. 18 divided by 2 is 9, so I'm left with -9. So I can come back up here, and in my table of values, when x is -4, y is -9. I can continue to do this here using this same equation. Okay, so I'll write this next one a little bit higher up. So 3x take away 2y equals 6. 3x take away 2y equals 6. This time I'm going to use the value for x equaling 0. So if we have 3x equals 0, take away 2y equals 6. Well, I know that 3 times 0 is going to equal 0, take away 2y equals 6. So now, since this is a 0 already, I don't need to add or subtract anything because it's 0. It's already like that. So really, I just have -2y equals 6. So now to get rid of the -2y, I just divide this side by -2, but I need to do that to this side as well, which gives me y equals 6 over -2. And we know 6 divided by negative 2 is just going to give us a negative 3. So I can put that value in here. And if I go 3x minus 2y equals 6, I can replace this x with a positive 4. This is going to give me 12 take away 2y equals 6. So now I'm going to want to subtract 12 from this side of my equation, which is kind of the opposite of what I did before. But I can't subtract it from one side without subtracting it from both sides. This 12 and that 12 will cancel. And now I'm left with negative 2y equals, well, 6 take away, I'm left with 6 take away 12. And again, to get rid of this negative 2, I have to divide both sides by negative 2. And that leaves me with y equals 6 take away 12 over negative 2. Y equals, well, 6 take away 12 is a negative 6 over negative 2. And since here I have two negatives, negative 6 divided by negative 2 gives me a positive 3. So I now have my table of values right here. And this wants me to draw, draw a graph of these table of values. So if I have my x and my y coordinates drawn, here I have, oh, I did that a little bit backwards. I should probably, because I have to go to a negative 9 on my y and a positive 3 on my y. Probably want to make my x-axis, which is going to be a negative 4. Oh, I see another thing I can erase right here. Okay, so now I have my 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, and then I have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. And I'm going to go to graph those 3 points. So I have negative 4 and negative 9, which is all the way down here. Then I have 0 and negative 3, which is right here. And then 4 and positive 3, which is right there. And these do indeed form a straight line. So that's how we do example A. And we graph that equation right there. So there was the equation. We substituted in each of these values just like we've shown there. We got negative 9, negative 3, and positive 3, just like we did in our table. And the line looks just like this one here. All right. So this is the new form that we've learned right here. AX plus BY equals C. And from this equation, we are still able to get a table of values. We're still able to graph. So if you have any additional questions about this or anything else discussed in this particular topic, please let me know. Please email me. And you can now go on and attempt to do questions 1 to 10 on page 178 and 179, I believe. All right. So thank you. Have a good day.